So, as I was discussing, according to classical mechanics, the ball can take any energy values, but according to quantum mechanics, the ball can take only discrete energy values. So, which one is correct? As I mentioned, quantum mechanics is correct. It can take discrete energy values, but our common sense tells us in our day-to-day life we see that the ball can take any energy values. So, you see the difference in energy levels between these energy levels. The nth energy level is this, the n plus 1 will be energy level would be n plus 1 whole square and this. So if I subtract the two, the difference in the energy level, I won't consider the n squared term or the subtraction term. We'll only consider the order of difference. So for a ball in a room, taking the length of the room, the date in day-to-day life we deal with distances in meters. So let's say, for approximation, let's say the length of the room is 1 meter, let us say, and the mass of the ball is say 1 gram. Definitely it is more than 1 gram, but let's say it is 1 gram, just to see the order of delta E, that is separation between the energy levels. So it is 10 to the power of minus 3 kg. If we just take the order, remember H, Planck's constant, is of the order of 10 to the power of minus 34. So it is a square over there. So you have a 10 to the power of minus 68 on top, delta E, divided by m, the mass of the ball is 10 to the power of minus 3 kg, and L square, the length of the room, is 1 meter, so it is 1. So you can see that the difference in energy levels in case of ball in a room is 10 to the power of minus 65 joules. Can you imagine? 10 to the power of minus 65 means there are 64 zeros in front of 1. So you can imagine how small these energy differences are, or how close these two energy levels are in case of our day-to-day life objects like a ball in a room. Just replace that ball by an electron. So for an electron in an atomic dimension, now we deal with electrons in atomic dimension. So the mass of the electron now becomes 10 to the power of minus 31 kgs, and the atomic dimension is 10 to the power of minus 10 meter, that is angstroms. So now again h square over here is 10 to the power of minus 68 order, just the order. Mass is 10 to the power of minus 31, and L square is 10 to the power of minus 20, and we get 10 to the power of minus 17. Can you see the difference over here? This has 16 zeros only in front of 1, and this has 64 zeros. This has 64 zeros. So look at the increase in the separation of energy levels when we go to the subatomic world. Now this separation in energy level increases as we go into the subatomic world, and quantum mechanics manifests itself. So why don't we observe it in our day-to-day life? Why in our day-to-day life the ball can take any energy values? Because the energy levels are so closely spaced, the ball can take any energy value over here. To us it seems that the ball can take any energy values, but actually the energy levels are discrete, but they are so close to each other, they are so close to each other, that to us it seems that the ball can take continuous energy values, but it doesn't. It takes discrete energy values, but they are very close. When does this closeness, or when does this separation increases? The separation increases, we can see, you can see the number of times the separation has increased in case of an electron in atomic dimension. So as you go into the subatomic world, the quantum nature or the quantized nature of energy levels manifests itself. It is there in our day-to-day life, but it is so small that we cannot observe it with our instruments that we have. No instrument can observe an energy difference of 10 to the power of minus 65 joules. No instrument. So to us it seems that it can take all the energy values, but that is not the case. It is the failure of our instruments. The instruments are not that precise to measure this difference and tell us that no, the energy levels are discrete. So the instruments with which we measure tells us that the energy levels or the energy that a ball can take is continuous. Actually it is not. They are discrete. So you see that quantum mechanics is right and classical mechanics is just the limiting case of quantum mechanics. In our day to day life, we do not observe the quantum effects because we are dealing with huge masses in our day to day life. Go to the subatomic realm, go to the subatomic world, and the quantum effects manifests itself. The quantized energy levels comes into picture. Now, you remember this was your wave function. The last word about particle in a one-dimensional box, the wave function was this. If you plot the wave function for different n values, you remember n can take 1, 2, 3 values. So I have plotted psi x for different n values. So this is what n equal to 1, that is psi 1 x will look like. This is n equal to 2, wave function would look like, and this is n equal to 3, wave function would look like. And what about the probability amplitudes? The probability amplitudes, that is the mod square, so definitely this is going to be higher because we are squaring it up. And in this case you have a negative lobe. If you square it, it will go up. So you have two lobes up. Again you have one lobe down, it will go up. So this will be mod psi 3 square. This is the probability amplitudes if you mod square it. So this finishes up particle in a one-dimensional box. Next we'll do particle in a three-dimensional box, which is an extension of particle in a 1D box. This is probably the most important part in your quantum mechanics module. Thank you.